In this lesson, we're going to begin building the linked list class. But before we do, I want to add one function to our node class. And that function is called setNext. And it takes a node pointer as an object and sets our next pointer to the node that's passed as an argument. And we're going to use this function in the linked list class to append a new node to the linked list. And in fact, now we're ready to begin defining the linked list class. So we're going to call this class LList for linked list. Everything is going to be public to keep everything simple. The one field that we need is a node pointer called head. And the reason we need that is that every linked list has to start off with a head node. And that's always the first node into the linked list. Without it, we wouldn't have a way to get into the list and then begin moving down next pointers. And we'll show you how that's set up in just a moment. After that piece of data, the next thing we need to do is create a constructor. All it does is have our head be assigned the value null, because we need to assign an initial value to the head node, and then every time we add a node, we'll exchange that value for head with the new node so that the new node is pointing to null. We're essentially adding nodes at the end of the list, much like with pushback with a vector, you add new elements to the end of the vector. So with that, we're ready to now move on down to the first function we're going to define, which is the append function to add a new node. So it's a void function. Its one parameter is the data we're going to put into a node. So we create the new node like so, just like that. Next thing we do is we create a temporary pointer to point to the head of the linked list. And the reason we do that is because now we're getting ready to determine where to put our new node. And we're going to look to see if there are other nodes already in the list, and if so, we're going to move down to the end of that list and append our node to the end of the list. So here's what we're going to do. We're going to say if temp is not equal to null, in other words, if it's not the last node, then move to a new node, move to the next node, and while that node is not equal to null, keep moving down. So the effect of this loop will put us at the end of the list. And then when we're at that point, we can say just like so. And that puts our node in the right position. And then we can say else. And this indicates that this last line, head equals new node, indicates that there were no other nodes in the list. And so our new node then becomes the head and the first node in the list. So with that, we're ready to look at one more function for this lesson, and that's delete. Delete takes a string data argument as the piece of data we want to try to delete from the list. So the first thing we do is we create a temporary pointer and point it at the head. Now we have a couple of tests to make. If this temporary node is null, then that means there are no nodes in the list and we can just return. Then we can test to see if we're at the end of the list. And so temp next equals null will indicate that we're at the end of the list. So we can delete this node and set the head equal to null, indicating that that's the end of the list. Otherwise, now we have to find the previous node because we're going to have to switch pointers. To get rid of a node, the previous node has to point from the node we're deleting to the node after the node we're deleting, if that makes sense. It will when we get to an example in the next lesson. So we create a previous node, and we write a do-while loop. Say if the data in this node is equal to the data we are searching for, then we're essentially finished. So break, set previous to the temporary node we just created, and then move to the next node. And do all this while temp is not equal to null. In other words, while there are still nodes left in the list to search for. Now here's where we adjust the pointers so that previous set next then becomes temps next. So in other words, what we're doing right here in this particular line is we're switching the node before the node we want to delete so that it points to the node after the node we're trying to delete. And then finally delete the node. And we're finished. That closes off our definition. And that actually closes off the class. Now let's build this to make sure we don't have any errors that we need to fix. And there's a simple little typo. Null is always a uppercase value. It's a special constant. All right, let's build again. and we have no errors. So the first two functions of our linked list are now built, append and delete. In the next lesson, we're going to see how to print a linked list so that we can test, and then we'll put some data into a linked list and see how well it works. And we'll do all that in the next lesson.